All right, so the test is 12 questions. It's going to be on 6.1 through 6.4. So remember, 6.1 and 6.2 is what the quiz was on. So look at the quiz review if you want extra practice for those type of questions. So solve triangles using law of sines, law of cosines, the area. So we have the sine area formula and Heron's area. So all of these formulas will be given to you. You just have to know how to use them. So reviewing 6.3 and 6.4 stuff. With question 1, it gives us an initial and a terminal point. How do I find the component form of V? So it's terminal minus initial. So it'll be -6 minus 7, and then 10 minus -4. So -6 minus 7 would be -13. And when you subtract negative, we add, so this would be 14. So our component form would be -13, 14. All right, next, the magnitude. So once we have component form, we can find the magnitude by taking the square root of the first number squared, so -13 squared, plus the second number squared. You could use the distance formula, but then you're just using these points, which you'll end up with the same answer. So once we already have component form, we can just kind of do the shortcut here. So -13 squared would be 169. And what is 14 squared? 196. So what's 169 plus 196? What is it? So the square root of 365. Always check and see if you can simplify your radical here. I don't think we can. No. So we don't have any factors that can come out here. So this would be our answer. Square root of 365. All right, for 3 through 6, we're going to use vectors u and v here. So first thing we have to do is add them. So we just add the first with the first and the second with the second. So 2 plus -3 and then -5 plus 5. So we're adding the first one with the first one, the second number with the second number. So our new vector is going to be 2 plus -3 would be -1. -5 plus 5 is 0. So u plus v is -1, 0. Any questions? All right, next. We're multiplying them by a scalar and subtracting. So always do the multiplication first. I have 2 times vector u, which is 2, -5, minus 5 times vector v, -3, 5. So when multiplying by a scalar, you have to distribute to both things in your vector. So this would be 4, -10, minus, I'm going to distribute the +5 and keep it a minus in the middle. But if you wanted to distribute the -5, you just have to change it to a plus in the middle. So this would be -15, 25. And then we just subtract. So 4 minus -15. This would be a plus. So that would be 19. The review. And then second minus the second. So -10 minus 25 would be -35. Any questions there? All right, 5, we have to take the dot product. 15 I got from distributing 5 to the 3. All right, so the dot product, when you take the dot product, your result's going to be a number, so it's not a vector here. So we want to find the dot product of u and v. So u is 2, -5. you multiply them together. So it'll be 2, well, I was rewriting it. So I'll rewrite the vectors down here so we can see it. So 2, -5, and -3, 5. So when we take the dot products, we multiply the first times the first and then add it to the second times the second. So this would be -6 plus -25. So it would give us -31. All right, number 6, we have to find the dot product, but first we have to multiply it by our scalars. So I have 7 times u, which u is 2, -5, and then 3 times v, which is -3, 5. So distribute first. So this will become 14, -35, dot product of -9, 15. So dot product, multiply the first times the first. So what's 14 times 9? 126 would be negative. And then add that to the second times the second. So it's -35 times 15. -525. And then we just add those two together. What do we get? -651. All right, number 7. So find the angle between the given vectors. So this formula will be given to you to find the angle between the vectors. It's cosine theta is equal to the dot product over the magnitudes. Thank you. So we have to find the dot product, find the magnitude of u and the magnitude of v, and then plug that into our calculator. So first thing we can do is find the dot product. So multiply the first times the first, plus the second times the second, and that would give us 8. And then we need to find the magnitude of u. So that would be the square root of 6 squared plus -2 squared. So 36 plus 4, which is 40. So the square root of 40. We don't need to simplify this because we're going to end up putting it in the calculator. So I would say don't simplify, because if you simplify, you could make a mistake and then the number that you're putting in the calculator is wrong. So for this, since this isn't our final answer, you don't have to simplify this. Next thing we need to do is find the magnitude of v. So it'll be the square root of 4 squared plus 8 squared. So the square root of 16 plus 64, which is 80. So we plug everything into our formula. We have the cosine theta is equal to 8 over square root of 40 times the square root of 80. So we put this into our calculator, but that's not our answer. We have to take the inverse cosine of that number. So the inverse cosine of whatever we get for that decimal. And what do we get for theta? 81 point something?
81.8.
We can say 81.8. And it's degrees. Don't forget the degrees.
And we have to memorize lifetime rounding, right?
Yes. The only formula from 6.3 and 6.4 that you're going to be given is this one. So you guys have to know how to find the dot product, how to find the magnitude. Yes, the unit circle will be given. It'll say.
Are we ever going to have to find the magnitude?
If we're given 2 points. Because 2 points would be parentheses. So if we're given 2 points, we would plug that in because that would be x2 minus x1 squared plus y2 minus y1 squared. But component form is x2 minus x1, y2 minus y1. So then when we take the magnitude, we can just take the first number in our vector and square it, and then plus the second number in our vector and square it.
So if it has arrows, it's component form.
Right. So this, with the arrows, is talking about a vector. With the parentheses, it's talking about a point. So if your answer is a vector, do not forget to put the arrows. So if you're talking about a vector, if you're giving me a vector, you either need to put the arrows or you need to put I and J. But just do the arrows. I think most of them will say like in component form. But if you're talking about a vector, you have to put the arrows. Yes.
Are we going to have to recognize the line on the graph like in the last line?
No, you won't have to graph the vectors.
So would it be easier just to find component form every time?
I think so. Because you're essentially doing the same math, because you're just plugging the two numbers, but you've already subtracted them. All right, so for number 8, we're doing the same thing. I have to find the dot product, the magnitude of both, and then just plug it in. So the dot product of u and v is the first times the first. So that would be 14 plus the second times the second. So 14 plus 8 is 22. Then the magnitude of u. So it'll be the square root of the first one squared plus the second number squared. So 4 plus 64. So the square root of 68. And then we have to find the magnitude of v. So that'll be the square root of negative 7 squared plus 1 squared. So 49 plus 1 is the square root of 50. Plug everything that we have in. So we have the cosine of theta is equal to the dot product over magnitude of u times the magnitude of v. If we put this in our calculator, that's not our answer because that's what cosine theta is equal to. So I have to take the inverse cosine of whatever this value is. And what does that give me here? 67.8. Do we agree? So 67.8 degrees. So that would be theta. So in putting this in the calculator, I would suggest putting whatever's on the bottom in parentheses if you do it all in one step. If you don't put parentheses, it's going to think that you're only dividing the square root of 68 and then you multiply the whole thing by square root of 50. So if you do it all in one step, make sure you use your parentheses to put it in the calculator. All right. So for 9 and 10, we have to find the dot product. So again, we're using that formula. I have cosine theta is equal to the dot product over magnitude of u times magnitude of v. So first thing I want to do is plug in everything that I have. So I know what theta is, I know what the magnitude of u is, and the magnitude of v. So I have cosine of 2 pi over 3, and that's equal to the dot product over the magnitude of u is 8 times magnitude of v is 15. How do I find the cosine of 2 pi over 3? The unit circle. So I go to 2 pi over 3 on the unit circle, and which value am I looking at here? Cosine tells me I have to look at the x values. So it'll be negative 1/2. So cosine of 2 pi over 3 is negative 1/2. And that's equal to the dot product over, what's 8 times 15? 120. And then from here, I'm just solving. So I can multiply both sides by 120. So it'll cancel out on the right. 120 times negative 1/2 would be negative 60. So negative 60 is equal to the dot product. You don't actually have to find the dot product of u and v. You just have to find what it is. So you don't have to find u and v. You just solve for whatever's on top here, which is the dot product. Yes. All right, number 10, we're doing the same thing. So here I have cosine of 5 pi over 6 is equal to the dot product over the magnitude of u is 7 and the magnitude of v is 22. What should I do first? Find 5 pi over 6 on the unit circle. So that would be here. And since it's the cosine of 5 pi over 6, what value am I looking at? The x value. So negative square root 3 over 2. So cosine of 5 pi over 6 is negative square root 3 over 2, and that's equal to the dot product over, what's 7 times 22? 144 or 154? $154. So then we're just solving for the dot product, so we can multiply both sides by 154. So it'll cancel out on the right. So I have negative 154 square root 3 over 2 is equal to the dot product. And then I can simplify this, so it'll be negative 77 square root 3 is equal to the dot product. So just simplify this. Don't multiply the square root 3 because then your answer is not going to be an exact answer anymore. So you just simplify whatever the fraction is.
Okay. So on the quiz,
So an example of side-side angle would be if it gives you this side, and this angle. So it'll give you a pair because this would be like angle A, B, C. This is A, B, C. So if it gives you like A, and then the one in between those, kind of. Because you have a pair here, so you do law of sines, but this is side-side angle. So if it's side-side angle, you have to check. Check for two triangles. So the last three questions say, prove that the following vectors are parallel, orthogonal, or neither. So if two vectors are parallel, they have to be proportional. So I'd put u1 over v1, and it has to be equal to u2 over v2. So like the first number in vector u over the first number in vector v has to be equal to the second number in vector u over the second number in vector v. If two things are orthogonal, if you take the dot product and they equal 0, it means they're orthogonal. And then if neither of these things are true, then it's going to be neither. Bless you. So it doesn't matter what you check for first. You can check parallel or orthogonal. It's kind of like, I guess, maybe like a 50-50 chance that it's going to be the right one first. But you could always check both of them and just do the extra work. But let's check and see if they're parallel. So I'll do the first number in u over the first number in v. And then that's equal to the second number in u, bless you, over the second number in v. Are these the same proportion? So these are not parallel. So let's check and see if they're orthogonal. So orthogonal means I have to take the dot product and see if I get 0. So first times the first, plus the second times the second. So that would be 30. So 30 plus 30 would be 60. Are they orthogonal? So they are not orthogonal. So then what do they have to be? So these are neither. All right, let's do the next one. Let's check and see if they're parallel first. So the first number in u over the first number in v is equal to the second number in u over the second number in v. I can simplify both of these fractions. So divide both of these by 2. I can divide both of them by 4. So this would be negative 1 over 2. I can divide both of the numbers in the second fraction by 7. So it'll be 1 over negative 2. Are these the same proportion? Yes. It doesn't matter if your negative's on the top or on the bottom. I have a negative in both of them. So it's negative 1/2 is equal to negative 1/2. So these are parallel. If you wanted to do the extra work and check and see if they're orthogonal, they're not going to be both. But you can maybe just check and see if they're orthogonal, see if you did the work wrong, if you wanted to. But they will never be both parallel and orthogonal. Something went wrong if you got both of them to be right. All right, 13. So we want to do the first number in U over the first number in V. See if that's equal to the second number in U over the second number in V. So I can simplify my first fraction to 1/2. Second fraction doesn't simplify. So are these parallel? Nope, so they're not parallel. And then let's check and see if they're orthogonal. So the first number times the first number plus the second number times the second number. So 18 plus negative 18 is 0. So these are orthogonal. So here we have a triangle. So A, B, C. B is given as 114. Side B is given as 4, and side A is 25. Of course, I picked one that didn't work. This one's going to be no triangle. But this is an example of angle, side angle. But let's do this as, I'll change B to be 40. That way it's kind of a little something different than what you've seen. All right, so B is 40. So I know that it's side angle, so I'm going to have to check for two triangles. So let's start with what we have. We have a pair. We have side B and angle B. So I'm going to do law of sines. So 40 over sine of 114 is equal to what? Perfect. 25 over sine A. So I'm solving for sine A first. I cross multiply. So I get sine of A is equal to 25 times sine of 114 divided by 40. So what do I get when I put this in the calculator? So I get sine of A is equal to 0.5709. Is that my answer? Nope. I have to take the inverse sine, because that's sine of A, but I want to find what A is. So the inverse sine of 0.5709 so I get angle A is equal to 34.8. So I know that I'm going to have to check for two triangles. I'm just going to get it started here now. So I have triangle 1 and triangle 2. So I start with the one that was given. So that was 114, angle B. So new angle B is going to be the same, 114. Angle A I just found was 34.8. So how do I find my new angle A? So I do 180 minus 34.8. I do still have to find C in the rest of them, but. So 180 minus 34.8, which is 145.2. Am I gonna have a second triangle here? No, because what do these two add up to? 259.2. So it's more than 180, so there's no second triangle. So I only have one triangle. So to finish solving my first triangle, how can I find angle C? How can I find angle C? I can't actually set a proportion because I don't have sides. I add the two angles and subtract from 180. So I have 114 plus 34.8. So that would be 148.8. So that gives me 31.2. So angle C is 31.2. And then last thing I have to do is find side C. So what can I do to find side C? Set up a proportion. So I'm going to use the same thing that I started with, 40 over sine of 114. And then that's equal to, I'm trying to find side C over sine of angle C, which was not that one, it was 31.2. So cross multiply and divide. So we get C is equal to 40 times sine of 31.2 over sine of 114. Put this into the calculator. So I get C is equal to 22.7. Don't forget to put units on the test if it gives you units. So again, only when it's side-side angle that you have to check for two triangles. If it's not side-side angle, you don't even have to check. Just solve the one triangle.